August 15th, 1977, Ohio. A radio telescope has been scanning the sky the way it does every day, slow, patient, methodical. At 10:16 p.m., it receives a signal. It comes from the direction of Sagittarius. It is narrowband, focused. Exactly the kind of transmission you would design if you wanted someone on the other side of the galaxy to hear you. The astronomer reviewing the printout the next day stares at the numbers. He picks up a pen. He circles the data and writes one word in the margin. Wow. The signal lasts 72 seconds. Then it is gone. For the next 45 years, scientists point every available instrument at that exact patch of sky. Hundreds of follow-up observations, the best equipment ever built. They find nothing. Not a repetition, not a confirmation, not a single additional transmission from whatever sent it. The galaxy offered us one clear sentence and then went silent. It has been silent ever since. To understand why that silence is so disturbing, you first have to understand the math that makes it impossible. The Milky Way contains 400 billion stars. If you tried to count them at a rate of 1 per second, you would have started before the invention of agriculture, and you would still not be finished today. Our sun formed 4.6 billion years ago. That makes us newcomers. The oldest stars in this galaxy have been burning for more than 13 billion years. Whatever could happen around a star, planets, oceans, chemistry, life, civilization, had a 9 billion year head start on us. NASA's Kepler telescope surveyed 150,000 stars and found that roughly 1 in 5 sun-like stars hosts a rocky planet in the habitable zone. Apply that fraction to 400 billion stars, and you get approximately 11 billion potentially Earth-like worlds in this galaxy alone. Include planets orbiting red dwarf stars, which outnumber sun-like stars by a wide margin, and the number climbs to tens of billions. The chemistry is not exclusive to Earth either. Astronomers have detected complex organic molecules in interstellar gas clouds, in the tails of comets, in meteorites that fall to Earth's surface. Amino acids form naturally in space. Water is one of the most common molecules in the universe. The raw ingredients for biology are scattered across the cosmos the way dust is scattered across a room, on everything, everywhere. The math is unambiguous. The galaxy is old. The planets are abundant. The chemistry is common. The time available has been immense. Something should have happened. Many things, many places, long before us. And yet, in 1960, astronomer Frank Drake pointed a radio telescope at 2 nearby stars and listened. Silence. The search continued. For decades, dozens of separate projects, thousands of star systems monitored across multiple frequencies. The Ohio State Big Ear telescope ran continuously through the 1970s. It produced the wow signal and nothing else. In 2015, Breakthrough Listen launched with $100 million in funding, using some of the most powerful radio telescopes ever built to survey the million closest stars, the entire galactic plane, and 100 nearby galaxies. It has now examined millions of star systems. Silence. In 2020, Australian astronomers published the most comprehensive radio survey of its kind. Over 10 million stellar sources observed. In 2015, a separate study examined 100,000 entire galaxies for infrared signatures consistent with civilizations harvesting energy at stellar scales. In July 2025, a rare interstellar object passed through our solar system, only the third confirmed visitor from beyond our sun's gravitational reach. Scientists turned their best instruments on it immediately, scanning every frequency. Nothing, just ice and dust falling through the void, on a trajectory that will carry it back into darkness without leaving a trace. We have been searching for 65 years with instruments of steadily increasing sensitivity. The silence is not a gap in the data, it is the data. So we reach for explanations. Maybe they are out there, but choosing not to contact us. Advanced civilizations observing Earth, the way a researcher observes a population that is not ready for contact. The zoo hypothesis. It is elegant. It mirrors something humans do. We establish nature reserves. We debate the ethics of reaching out to isolated tribes. A civilization millions of years ahead of us might apply similar principles to a species that has only just learned to split atoms. But the zoo hypothesis has a fatal weakness. For it to explain total silence, every single civilization in the galaxy must independently arrive at the same decision. Not most, every one, across billions of years and potentially thousands of separately evolved intelligences. Not one species, not one faction within a species, not one individual with access to a transmitter breaks the quarantine, not even by accident. Human civilization cannot achieve unanimous agreement among nations sharing a single planet. The idea that thousands of alien civilizations, separated by light years and operating under completely independent evolutionary pressures, achieve perfect permanent consensus stretches credibility past its breaking point. One defector is all it takes. Maybe the galaxy is simply too vast. Signals weaken with distance. Light takes 100,000 years to cross the Milky Way. Maybe no one can reach anyone. But distance is a barrier to conversation. It is not a barrier to expansion over deep time. In 1980, physicist Frank Tipler calculated that a civilization using only technology that is physically plausible could build self-replicating probes. Machines that travel to a neighboring star, use local resources to build copies of themselves, and send those copies onward. A wave of such probes could reach every star system in the Milky Way within 1 to 10 million years. The galaxy is 13 billion years old. That process could have run to completion more than 1,000 times over. If even one civilization anywhere in this galaxy's history had launched those probes, they would have arrived here millions of years ago. We have examined our solar system. We have mapped the moon's surface, which preserves a record stretching back billions of years. There is no sign of visitation. There are no artifacts. There are no probes waiting at gravitationally stable points between planets. Nothing. Each explanation, under pressure, collapses. And that forces the question into much darker territory. In 1998, economist Robin Hanson named what the silence implies: the Great Filter. Somewhere between a barren planet and a galaxy-spanning civilization, there is at least one step that almost nothing survives. One bottleneck so difficult, so lethal, that across billions of years and billions of chances, virtually nothing makes it through. The question that changes everything is where the filter sits. If it is behind us, if the impossible step was something in our past, then we are survivors. We are the rare ones. The galaxy is quiet because almost nothing else ever reached this point. Consider the candidates. Life appeared on Earth within a few 100 million years of the surface, cooling enough for liquid water to exist. Some scientists take that as evidence that life arises easily, but we have a sample size of exactly one. Every organism on this planet, from bacteria to blue whales, shares the same genetic code, the same amino acids, the same core biochemistry. If life arose easily, you might expect it to have started multiple times independently. It did not. Despite 4 billion years of biology and trillions of cellular interactions happening every single day, the origin of life happened once. No laboratory has ever produced a self-replicating cell from scratch. The transition from complex chemistry to living biology remains one of science's deepest unsolved problems. Go further. Life appeared 4 billion years ago. For the next 2 billion years, all life was single-celled. Bacteria, simple, successful, but fundamentally limited. Then a single cell engulfed another cell and, instead of digesting it, kept it alive. Over millions of years, that engulfed cell became mitochondria, the structures that power every complex organism on Earth. Every animal, every plant, every fungus descends from that one event. In 2 billion years of microbial life, it happened once. And even if complex cells emerge, intelligence is not guaranteed. In 540 million years of complex animal life, with hundreds of millions of distinct species, exactly one developed the ability to build a radio telescope. Sharks have survived 450 million years without a single thought about astronomy. Intelligence is not an inevitable destination. It may be a statistical accident, a contingency that almost did not happen. If any of these is the filter, if the hard part is behind us, then the silence means we are extraordinarily lucky. It means the galaxy is filled with planets that got partway through the process and stopped. Oceans without animals, microbes without minds, minds that never reached for the stars. But there is another possibility, and it is the one that changes everything. What if the filter is ahead of us? 1983, a Soviet early warning satellite detects what appears to be 5 incoming American nuclear missiles. The officer on duty is Stanislav Petrov. He has minutes. The protocol is to report up the chain immediately. He does not report it. He believes it is a malfunction. He has no proof. He waits. He is right. The satellite failed. But if another officer had been sitting at that desk, the response might have been different. October 1962. A Soviet submarine near Cuba loses communication with Moscow at the height of the Cuban Missile Crisis. American ships drop practice depth charges to force it to surface. The crew has no way to know whether war has already started. 2 of the 3 senior officers vote to launch a nuclear torpedo at the American vessels. The third, Vasily Arkhipov, refuses. A single dissenting vote on a submarine cut-off from the outside world is all that stops the event from becoming the opening act of a thermonuclear war. 1995. A Norwegian research rocket triggers Russian nuclear alert protocols. President Boris Yeltsin has minutes to decide whether to order a retaliatory strike. He waits. 3 times in 50 years, the survival of human civilization came down to the judgment of one person, acting under extreme pressure with incomplete information. Now run the math across deep time. Imagine a civilization with a 2% chance of self-destruction per century. That sounds manageable, but compound it. After 1,000 years, cumulative survival drops to 82%. After 5,000 years, 36%. After 10,000 years, 13%. A civilization needs to survive for millions of years to leave the kind of presence that resolves the Fermi Paradox. At 2% per century, the probability of lasting 1 million years rounds to 0. The filter does not require a single catastrophe. It only requires that technological civilizations are unstable over long time scales, that the tools they build to grow are the same tools that can destroy them, that across enough centuries, something always goes wrong, not because the universe is hostile, because intelligence is powerful, and power without sustained wisdom across geological time, without a single fatal error, that may be a condition nothing has ever managed to achieve. And there is a version of this that is quieter and stranger. Every generation of tools has been more capable and more autonomous than the last. Stone gave way to metal. Mechanical systems gave way to digital. Digital systems are now giving way to artificial intelligence. The trajectory points toward a threshold where machine intelligence surpasses human capability across all domains. What happens after that depends entirely on what the machines want. Biological organisms evolved curiosity, the drive to explore, the restless need to know what is beyond the horizon, because those traits aided survival. A machine has no evolutionary history. It has no instinct to reach outward. It has no reason to broadcast. A post-biological civilization might be completely invisible, not hiding, not making a choice to stay quiet, simply indifferent to everything that would make it detectable. The filter may not be destruction. It may be transformation into something that no longer has a reason to be seen. The evolutionary biologist Ernst Mayr argued this directly. Intelligence, the kind that builds telescopes and asks about distant stars, has existed on Earth for an almost immeasurably brief interval. Bacteria have persisted for 4 billion years. Insects have dominated land for 400 million. Our species has existed for 300,000 years. The capacity for nuclear self-destruction has existed for less than a single human lifetime. His conclusion was blunt. Intelligence may be a lethal mutation, a trait that confers enormous short-term advantages, the ability to outcompete everything, to harvest energy at planetary scales, to reshape ecosystems, but that carries within it a fatal long-term flaw. The same power that enables dominance enables self-destruction. No bacterium has ever built a weapon capable of sterilizing its own planet. No insect colony has ever destabilized the climate system that sustains it. These are uniquely intelligent achievements. Fermi asked his question over lunch in 1950. He spent less than an hour thinking about it. He could not have known that 75 years later, with vastly more data and vastly better instruments, we would still have no answer. The silence has only deepened. In that silence is a thought that is difficult to sit with. Every answer to the Fermi Paradox, whether the filter is behind us or ahead or distributed across the entire journey, carries the same implication. That what we have right now, this brief window, this single century of electromagnetic visibility, this fragile interval between the discovery of fire and the invention of weapons that can end everything, is not guaranteed to continue. It is not a permanent condition. It is a moment, and moments end. There is a way to feel the weight of this. Imagine the Milky Way as a dark room, 100,000 light years from one end to the other. Every civilization that has ever existed is a match struck somewhere along that room. The match flares. It burns for an instant. Then it goes out. If you struck 1,000,000 matches at random points across 13 billion years, most would burn alone. The room would never be empty, but no two flames would be lit at the same time. A visitor arriving at any random moment would find only darkness. We are a match. We have been burning for 1 century, measured from the moment our radio signals first reached into space. The flame is bright right now. We can see by its light. But the room is vast and very dark, and we do not know how long we have left. The most unsettling possibility in all of science is not that we are alone in the universe. It is that we might be ordinary, that civilizations like ours arise, develop radio telescopes and nuclear weapons in the same decade, ask Fermi's question, hear the same silence we hear, and then go dark within a few centuries. Not because they were unlucky, because the pattern is built into what they are. The galaxy has been running this experiment for 13 billion years. The result is silence, and we do not yet know whether we are the exception or the rule. Subscribe to the Cosmic Deep. Next time, Mir, 15 years in orbit, a fire, a collision, and a controlled fall from the sky, watched live by millions of people on the ground below. The void remembers what history forgot.